Hello guys, in this video I would like to explain about that how we can visualize correlation in R and RStudio. And as you know, we have done previously some videos in R and Python about correlation analysis. In Python we have done two videos about linear correlation analysis and then non-linear correlation analysis using Spearman-Rho correlation and Kendall-Tau correlation. And then we have done the same in R and RStudio. But I think this is important. Sometimes you need to display the correlation between the two observation, like the plot which you can see on the screen. And you can see this is the line, the regression line, and the correlation is R is equal to 0 minus 0.74. The p-value is 4.3 a raised to power minus 9. And these shaded areas are the 95% confidence interval of the line. So this can give you some good information about the correlation, and then in the confidence interval about the line. And sometimes you need these type of plots in your study, your thesis paper, and maybe technical report, etc. So the question is how you can visualize the correlation and how you can create the plot which you can see on the screen here. For this plot, we need to use R, and I will try to do this in Python in the next video sometime, some other time, not today. So let's go to RStudio and see how we can do this. Okay, just wait for a moment. Okay, again, we will use the empty cores data, which I explained earlier. And if you want to know further about this, detail about empty cores data, the link to the video in which I explain this is given in the description of this video. So you can go just click and see what is meant by the empty cores data and what is this data, what are the variables, and so on. So just take this data as we have done previously 2 times, and then just see what. Okay, so these are the variables, and you can see core types and in the variables. And now select these three variables from all these variables, and then just assign x to this mpg variable, y to hp, and z to a wt. Now if you want to display the correlation, like to create like plot like this, you need to use this or library, this one. So I already installed, I don't want to run it again. You need this, so just look at this, note this ggpubr, and I will just import, or you can say call it. So yes, okay, it's worked, so fine. Now you can see that data. I'm just creating data frame and which store the data in data, and this is from xy. Remember that what is x? X is mpg variable. This variable is in x now. This is stored in x, and y is hp. Okay, y is hp. Okay, you can say like, because actually this mpg mileage is dependent variable, so you can store this like y and this x. So you can do like that, r, and yeah, you can do like this, no problem. This is in fact y, it is dependent variable, and this is in fact x. and this is Z, this is okay. So this should be the Y variable. So now you have X and Y. X is HP, the horsepower, and Y is the MPG. Like this, and this should be, you can write X on X and Y on Y labels, or you can write X label HP and Y label MPG, mile per gallon. Okay, and this function will now create this plot, GG scatter plot data, which is this one, and these are the variables. So Y on Y, X on X, and add regression line. So this means that this will add a regression line to the scatter plot, and coefficient confidence interval. So this will uh, add confidence interval, and then this is the correlation coefficient. So this will add the correlation coefficient. I mean, like OR, and this is core method. So you can use any other method, but it is mentioned Spearman. So this will mention Spearman. You can mention Kendall. So then they will do that Kendall, like I have done this. So you can do both of them, no problem. So, and then yeah, these are the labels. So whatever the labels you have from your data, you can do like this. Just run this. Okay. Yes. So this is working. It's good. And you can change the color as well. No problem. This is not necessary. So just play with the code. Uh, these are the data point, the black lines, the black dots. The line is the regression line which we have added. Add regression line, and the blue, the shaded region is the 95% confidence interval. Yeah, confidence interval is true, and correlation coefficient, that is equal to or is equal to minus 0.89, and p value is this one. So you can test in the same plot. This give you a test of the correlation coefficient. This is significant correlation coefficient. So the null hypothesis is that correlation coefficient is 0. There is no correlation coefficient. And if you see, this is not actually, the p-value is very, very less. So we reject the null hypothesis and conclude that the correlation coefficient is not equal to 0. It is significant correlation, and of course it is significant. So now just play with the code. That's how you can just, this is now, just remove this, and you will see, just remove this. You will see the graph then. So no regression line. So regression line is removed. The correlation is there, and there is no confidence interval because there is no line in fact. So you need this line, then you can have the confidence interval. Just try this false ls, and now run the command. So you will have no confidence, the shaded region. You will have only a line. So this is the line. So this work, when you say true, this means that this will give you that 95% confidence interval. True. You can run again and you will see. Okay. And now, if you want to make this false correlation coefficient, ls, and run it, you will have no correlation coefficient and no p-value on the top. Nothing there. So you can, these things are very important for this plot, and you can see each part has its own importance. So you can make this true and run it. So you have a lot of information in the single plot. You have the plotted data, the square plot data, HP, and the MPG. And you have in the regression line, you have their 95% confidence interval, and you have correlation coefficient, and you have a p-value. So you have a lot of information from single plot by using this. So you can do like this, and you can change the color. If you don't like the color, you can change the color. Just writing scroll, just say red. So you have red color. Make it blue. You can make it blue color. Just write blue. So this is now the blue color. So you can change the color as you like. Magenta. So this is magenta. Whatever you like, you can change the color, no problem. So this is about Spearman rank correlation, Spearman rank correlation, and you can use the Kendall tau as well, the same data frame, and XLab again. I changed this already, so now the only difference is Kendall tau now. This is Kendall test now, the method, and all the things are similar, so you can do in the same way Kendall tau correlation. You know, to visualize the correlation using Kendall tau, and I already explained in which situation you can use this. So if you want to know about in which situation you need to use this, just have a look at the description of this video, and a link is given about in which situation you can use Kendall tau correlation and Spearman rho as well. Now run this, and you will see at least you will see a different coefficient here, because this, I explain in the video that in which situation you need to use which correlation method, because the result can be changed in fact. So just run this. Look, the correlation was minus 0.89 and now it is minus 0.74. The p-value is also little change. So the same thing, but this is now with the Kendall tau. So sometimes you need to Kendall tau, sometimes you need Spearman rank correlation, and sometimes you need simple correlation, linear correlation analysis. So this is important to know that how you can create this plot. Sometimes you need this for important documents. And what we have learned in today's video, we have learned that how we can prepare data for such type of plot, and how we can create this plot, and what this plot actually give you. This plot give you a scatter plot between the two variable like horsepower and mile per gallon. And then this plot give you the regression line here like this, and then this line give you the 95% confidence interval for this regression line as well with the shaded region. And this line, this plot give you the correlation coefficient and the p-value of this correlation coefficient, which tests the correlation coefficient whether it is significant or not. So these are multiple information in this plot, and maybe sometime you need this very simple code, and or you can do this very easily, create this plot for your data. And if you have any problem, you can write me in the comments, and I will try my best to answer that as soon as possible. So I think it's enough for today, and thank you very much, and see you in the next video. Ciao.